Hello, my name is Ardi and we are going to solve this problem here. So the question is find the Thevenin equivalent of the circuit at terminals A, B. Okay, but the real problem is that we have this dependent voltage source here that we need to take care when we are looking for the Thevenin resistance. So usually for finding Thevenin equivalent, we need to step here. The first one will be to find the Thevenin resistance, and then the second one will be to find the Thevenin voltage. And maybe let's do it one by one here. To find RTH, we need to turn off all the independent sources, all the independent sources. Okay, let's see our circuit here, and we only have this 5 ampere current source as the independent current source. This is a dependent one, so we do not turn off this. So we turn off this one, and current source, we replace it by open circuit, right? So we replace this by open circuit. Okay, maybe let's redraw the circuit first. So to find out the RTH, this will be replaced by open circuit, so I don't draw it. And now we will have this 4 ohm resistor here. This one is here, 4 ohm. But then the voltage across it is Vx. Okay. And then we have this 2 ohm resistor here. So we will have that 2 ohm resistor. And then we also have this 6 ohm resistor. Okay, 6 ohm. And then we still have this 2 ohm resistor here. 2 ohm. And so this is terminal A. And here we will have terminal B. But remember, we still have this dependent voltage source. Okay, maybe let's move it a bit to the bottom here, so I get some room. And we still have that dependent current source, I mean voltage source. So let's draw that. So we'll have this one here, like this. And the value will be 2Vx. 2Vx. Okay. Usually we need to take this equivalent resistance here. So this is the RTH. However, we have this problem here. We don't have any sources, so this Vx will be 0, right? So we also lose this dependent voltage source. So what can we do here is we place a dummy source in the terminal AB. So let's put this 1 volt voltage source. So we put 1 volt dummy source here. And then we know that this will generate the current there. So let's name this I0. So we can find RTH. So let's take a note here. So RTH will be 1 volt divided by I0. Good. And I think we can start doing circuit analysis from this circuit here. Okay, I will use KVL here, or I will use loop analysis for this circuit here. Okay, let's use this loop here. Why? Because we already named this one as I0, so we can get I0 from here. And let's name this loop here as I1, and then this loop here as I2. So we can do KVL at loop I0, I1, and then I2. Okay, let's exactly do that. Let's do KVL at I0. KVL said that the sum of the voltage in a loop will equal to 0, right? Okay, so now let's start from this 1 volt dummy source. The current is flowing from negative terminal to positive terminal, so I will have minus 1 here. Okay, and then we move to that 2 ohm resistor, but we need to multiply it by the current to get voltage. So I will have 2I0 here. Then we move on to the last component here, so we will have 6. But then we are working on I0, so I0 came first here. But then here I1 flowing to the opposite direction, so I subtract it with I1. Okay, good, and all of that will equal to 0. Okay, we can simplify this, right? So we can get 8I0, and then minus 6I1, and that will equal to 1, right? Good. Now let's move on to KVL at I1. Let's do KVL at I1. KVL at I1. Again, KVL said that the sum of the voltage in a loop will equal to 0. Good. Let's start from this 6 ohm resistance. So I will have 6. We are working on I1, so I1 came first. But here I0 flowing to the opposite direction. So I will have minus I0. Good. Then let's move on to that 2 ohm resistor. So I will have 2 multiplied by I1. But here I2 flowing to the opposite direction, minus I2. Good. Then we will have plus 4 ohm there. And the only current that pass through it is I1. All of that will equal to 0. And I think we can simplify this. So we'll have minus 6 I0. And then for the I1, I will have 6 plus 2 plus 4. That will be 12. So I will have plus 12 I1. And then finally minus 2 I2. Okay, and all of that will equal to 0. Good. Now let's move to the last loop here, which is I2. Let's do another KVL here. KVL at I2. So KVL said that the sum of the voltage in a loop will equal to 0. And here we will have this one here, 2. But now we are working on I2, so 2I2. And here I1 is flowing to the opposite direction, so minus I1. And then here we will have the current going to this voltage source, and then it enters from the positive terminal, so I will have plus and then 2 Vx, right? Because the value here is Vx, and all of that will equal to 0. Okay, I think I need to clean up a bit here, so let's simplify things. Okay, I have erased some unnecessary calculation here. So let's replace this Vx. What is Vx? Vx is I1 multiplied by 4, right? So I will have 2I2 minus 2I1, and then plus 2 multiplied by this one here, which is 4I1. Okay, and all of that will equal to 0. Good. Now, what can we get from here? Oh, that is not 2I1. So we will have minus 2 plus 8 will be 6. So I will have 6I1. Okay. And then we can get, what else? Plus 2I2, right? Plus 2I2. And that will equal to 0. And let's see here, we have 3 equations and 3 variables. 1, and then 2, and then 3. Okay? And we should be able to solve this, right? Using calculator. So we will have this here. Let's set up our calculator as complex solver. So I will have number 5, not complex equation solver. And then we have 3 variables. We have I0, I1, and I2. So I will have number 2. Okay, let's plug that in. I will have 8 and then minus 6. But then here the coefficient of I2 is 0, and all of that will equal to 1. Good. And then the second one, I will have minus 6, and then 12, and then minus 2. And all of that will equal to 0. And here for I0, I will have 0 as the coefficient, and then 6, and then 2, and that will equal to 0. Good. So we will have the value of I0 here is 1 over 6. So I will have I0 is 1 over 6. I0 is 1 over 6 ampere. And then what is I1? I1 here is 1 over 18. 1 over 18 ampere. And then I2 is minus 1 over 16. Minus 1 over, not 16, 6 ampere. Okay, that will be nice because we know that RTH is 1 over I0, right? So we know I0 here. So RTH is just 1 divided by 1 over 16. So I'll have 1 divided by 1 over 16, and that will be our RTH value, which is 6 ohm. Good, and this is one of the important values that we need from here. Okay, that is to find RTH. But then we still need to find out the Thevenin voltage, VTH. Okay, let's clean up the slides and work on VTH. Okay, now we need to find one more thing, which is VTH. And what is VTH? VTH is actually the open circuit voltage, right? Open circuit voltage at AB. Okay, so we need to find out what is the open circuit value here and here. But here we have to find out the open circuit. So there is no current that goes through this 2 ohm resistor, right? So the voltage here will be the same as this node here. So this is the node A here. So I will have VA is this node here. And I think we can just replace that 2 ohm resistor using by short circuit, I think. Yeah, let's replace that. So we will need to replace this by short circuit. Okay. And we will have it like this. Good. And let's set this. Let's set this as our ground here. So the voltage here, which is VB, actually is equal to 0. Good. But then in this node here, we have P, let's name this as PC, right? PC. Good. But then we have a dependent source here. So I think I will need to use super node for this case here. Let's do exactly that. Let's do this one here, which is a super node. Let's do this as a super node. And then let's assume the direction of the current. For this, I just follow the direction. So it going up and then goes to the right. And here I assume it's going down, and this is also going down. And this 2 ohm is not necessary because we know the voltage between it actually. Okay. Let's see to use KCL at the super node. Okay, let's use KCL at super node. So we will have the sum of the current that goes in that will equal to the sum of the current that goes out. Good. The only current that goes in is this one, so I will have 5 ampere. And then the other currents are going out, so that will be this one here. So I will have PC, and the current goes to the ground, so I will have VC minus 0 divided by the resistance between them, which is 4. Good. And then we will have this current here, so I will have VA minus 0 because it comes from here and it goes to the ground. So I will have 8 divided by 6 like this. Multiply both sides here by 12. So we will have 60 on the left hand side, and then 4 and 12 will cancel into 3, so I will have 3 VC and then plus 2 VA. Good. And now we will have 2 VA plus 3 VC is equal to 60. Good. Let's have this as equation number 1. However, we still need one more equation, right? But then we know from this dependent voltage source here that VA minus VC is equal to 2Vx, right? So VA minus 2VC, VA minus VC, is equal to 2Vx. This is from dependent voltage source, right? And then what can we do from here? Okay, we still have VA minus VC here, but we need to take care of the Vx. But what is Vx? Here, Vx is the difference between this node here, which is VC, and then this node here, which is VB. But then VB is 0, so I'll have minus 0. So we'll have VA minus VC is equal to 2VC. So therefore, VA minus 3VC is equal to 0. And this is equation number 2. Good. And now what can we do from here? Let's use calculators to solve this 2 equation, right? We have 2 equation and 2 variable. Let's set this up, and then equation solver is number 5. 2 variables is number 1, and we can just plug the coefficient. 2, and then 3, and then 60. Good. And then the second one will be 1, and then minus 3, and 0. So we can get the value of VA, which is 20. So I will have VA is equal to 20 volt. And also VC here, that will be 20 over 3. So I have 20 over 3 volt. Good. But we are asked to find out VTH, which is VAB here, which is this one here. So VTH is this one. So we will have VTH is equal to, what is it? VA minus VB, right? VA minus VB. But then VB is 0, right? Because this is our ground. So we will have it as equal as VA. Therefore, we know that our VTH here is equal to VA, which is 20 volt. Okay, very good, because we have VTH and RTH. Okay, let's clean up the board and let's make a conclusion here. So the last step is just drawing the Thevenin equivalent circuit. So what is our Thevenin equivalent circuit? So we can just draw it, a voltage source here, which is VTH. So we will have VTH here is equal to 20 volt. Good. And then that will be in series with this parallel resistor. I mean a series with a resistor here. So we'll have that as RTH, which is 6 ohm. And then that will be our terminal here. This is terminal A and this is terminal B. And therefore this is the Thevenin equivalent of the circuit. Hopefully I did not make any mistakes, but I think I did not make any mistakes because this is the same as the example in the book. So hopefully you will understand from this step-by-step tutorial. Thank you for watching. See you in the next video. Bye bye.